All right, today we are going to tackle a question that really is at the very heart of medicine. Where does disease truly begin? And I'll tell you, the answer might not be what you expect.
Have you ever wondered about this? I mean, think about it. A new virus starts going around, right? And for some people, it's just a sniffle, barely anything. Others get hit really hard, and some, tragically, don't make it. It's the same exact bug, so what's the deal? Let's dive in and figure this out together.
Okay, so to get started, we've got to zoom way out. I'm talking about looking at the big picture, kind of like a detective investigating a massive case.
So when health experts look at an outbreak, they see something that looks a lot like this chart. You might have, say, 10,000 total cases. But look closer. The real story's in the breakdown. You've got a huge number of mild cases, but you also have this really significant chunk of severe ones. Why? Why the huge difference? Well, finding the clues in these massive population-wide patterns, that's a job for a very specific type of science. And that field, it's called epidemiology. You should think of epidemiologists as the master detectives of public health. Seriously. They're not looking at just one person. No, they're looking at whole cities, entire countries, sometimes the whole planet, to figure out the who, what, where, and when of a disease. They're hunting for clues in the data, trying to see who's most at risk and where this thing is spreading.
But here's the thing about those big population-level patterns. They aren't just numbers on a spreadsheet. They're made up of individual stories. Every single data point you saw in that chart, that represents a real person, a real experience.
In fact, the entire story of a global pandemic, believe it or not, starts with a tiny microscopic event happening inside just one body. So to really get what's happening on a global scale, we have to zoom in, like way in. So now we're shifting gears. We're going from that detective's wide-angle camera lens to a forensic expert's microscope. We're about to read the biography of a disease, you could say, as it plays out right inside the human body. And this microscopic story has a name: pathogenesis. So if epidemiology is the big detective story of who gets sick, pathogenesis is the forensic story of how they get sick. It's the play-by-play, the biological narrative, from the moment a virus or bacteria gets in, all the way to when you start feeling symptoms. It's basically the disease's origin story. You can think of it like a little 4-act play. So, Act 1, exposure. You cross paths with the bad guy, the pathogen. Act 2, cellular invasion. It manages to break through your body's defenses. Act 3, molecular malfunction. It gets inside your cells and starts messing with the machinery. And the grand finale? Act 4, symptoms emerge. It's only after all that tiny microscopic drama that you actually start to feel sick. This internal story, it dictates everything. So we've got these two amazing fields of study, right? One looks at millions of people, the other at millions of molecules. But the real magic, the real breakthrough, happens when you bring them together. Let's just lay it out, side by side. You've got epidemiology, giving us the who and the where, all the patterns across the population. And then you have pathogenesis, giving us the how and the why, the biological process inside one person. For a long, long time, these two fields kind of did their own thing. But the real game changer is when you finally connect them.
And that bridge, that connection, is a super powerful integrated field called molecular pathological epidemiology, or MPE for short. This is it. This is the moment where the disease detective and the forensic expert finally get to work together on the very same case. MPE is what lets us draw a direct line from the tiny molecular story happening inside a single cell to the giant patterns we see across an entire population.
What this creates is one single unified field for understanding disease. And all of a sudden, we can ask these incredible new questions. Questions like, hey, could a tiny specific genetic mutation explain why one whole neighborhood has higher rates of severe illness than another? Connecting the micro to the macro, it's a complete game changer.
And look, this isn't just some cool academic idea that scientists talk about. Connecting the big and the small has huge real-world consequences for every single one of us and our health.
Because think about it. When you know exactly how a disease works on a molecular level, you can fight it so much smarter. This means we can design drugs that hit its precise weak spot. It means we can move past generic health advice and start creating personalized risk profiles. And it allows for public health interventions that are almost surgical in their precision, getting the right resources to the exact people whose biology puts them most at risk.
You know, this quote just hits the nail on the head. It says it all. You can't really control a wildfire if you don't know what kind of fuel is burning. And it's the same idea here. You can't truly control a disease across a whole population until you understand the molecular fire that's burning inside each individual.
So after all that, what's the one big idea you should walk away with? Let's just boil it all down to its core.
This is it. This is the key. To protect the crowd, we have to understand the cell. Public health and personal health are not two different things. They're two ends of the very same thread. The health of our entire society is built, fundamentally, on the incredibly complex, microscopic stories happening inside each and every one of us. And that really leaves us with this final kind of powerful thought. Every single one of our bodies is like a living library of biological information. Just imagine the amazing breakthroughs in medicine and public health that are just waiting for us, if we can only learn to read all of those individual stories, together on a global scale.
Hey, thank you so much for joining me for this explainer. If you found this useful, definitely hit that like button and subscribe. We would also love to hear from you in the comments. Let us know what topic you want us to break down next. See you next time.